Okay, so yesterday we were speaking about the stateless firewall and stateful firewall. Okay, so you can assume um, you have the router, okay, in your environment. So suppose 1 minute, I have to open the pen. So team, this is very important, the theoretical part. After that, we will jump on the firewall immediately. But this is very important to understand this entire flow and the logic. Okay, if you will understand these things, it will be easy to understand the firewall and all other mechanism of the firewall. Okay, so suppose you have the router here. Suppose this is the router, okay, and this side here is the PC. This is the PC, and this is the server, right?
అది ట్యాబ్ కొంచెం చూడు పండి.
Yeah, Bala, can you please put yourself on mute? Thank you. Okay, so once this system, this PC will send or try to access the application or try to ping on that server, what will happen? So it will send the packet just like this system is pinging or sending any request to access the application. Let's assume. Okay, so it will send the TCP send request to that particular application or particular service. So in the packet, what will happen? It will create or generate the packet. Okay, so here it will put the source IP. Okay, and then source port, and then it will put the destination IP and the destination port. Okay, so suppose the IP address is for example 10.1.1.10. Okay, and the source port is randomly it is assigned to, as we discussed yesterday, 3050. This is the random port. Let's assume you are using the pet overloading with this device, and then the destination PC or let's say server, it's using the 150.1.7.100. Okay, and the port number is suppose port 80, or you can assume another port for port 3 or any other port based on your requirement. So here the router fast Ethernet 0x0 interface, here fast Ethernet 0x1. Okay, so what will happen? First it will process the packet. Okay, if anyone is having any doubt or any question, immediately raise the question. I will clarify that. Okay, so this PC will generate the packet, and the packet will use the ICMP protocol or ARP protocol, and it will bundle the packet and it will go to the NIC of the PC, this interface card NIC. Okay, so it will first it will check that what is the packet and what is the gateway, all the things, source IP, destination IP, source port, destination port. Okay, all the things it have. Okay, but it don't have the gateway information, for example. So it will put the source IP and source port, destination port, all the things, but if it don't have the information, so it will put the broadcast broadcast address. instead of IP address to get the information about its gateway. First, it will the broadcast packet will hit on this router. Okay, it will gather the information, MAC address and the IP address of this router, put in the packet, correct the packet, and packet will process from the system and hit on the router. Router will go and check many things on this interface at fast Ethernet 0x0. Okay, before processing the TCP SYN request. Okay, so okay. Okay, so when this router will receive this TCP SYN request, this will process the packet, and what it will do, it will process this request at the ingress stage, means it will check the packet on interface fast Ethernet 0x0. It will check the CRC, redundancy check, errors, okay, runs, giants. You know what is the runs and giants? Anyone? Anyone can speak about the runs and giants? Okay, so here I am checking the interface one here 0x0. Show interface E0x0. Okay, here you can see many parameters are there. Okay, here you can see runs. Oh my god. Okay, so here you can see the runs. Here it is giants, totals. Okay, so runs mean if the packet size is less than 64, that means it is very small packet, so it will not process that packet. Okay, so that is called runs. If the packet size is more than 1544, so that packet will be the giant packet. Okay, if we are using the Nexus switches or high-end switches, so there may be the another thing happen in the picture. What happens, they are processing the packet just like they are doing the fragmentization with the jumbo packets. Okay, I think you should know about it. So uh, if the giants packet are coming and more jumbo packets are coming, so throttling may happen with your bandwidth. Okay, it will check the input errors, CRC errors, RAM, all the things. Okay, how many packets it's processing. So you can see here all the things. So these things it will check. Okay, so it will check the packet is properly formed or not. It will check the header of the packet, and then it will check the source IP address, destination IP address, source port, destination port, or if it receives the fragmented packet, then it will do the IP reassembly, all such type of task. After that, the router will also do the checks on the network address translation. If in your router net is running here, okay, there is a public IP address and a private IP address in between. So organization may use the netting on the router also. Suppose they took the bandwidth from particular ISP, and the size of the network is slash 30, or let's say slash 29 sider. So in that situation, they may do the netting on the router to assign those 4 or 6 IP addresses to particular devices or servers internally. One IP to mail address server, one IP to the proxy server for internet, and one IP to another application server, direct connectivity, one IP for global FTP server for that particular organization. So if they are using the netting, then network address translation it will check, and the router will also check the access control list. If we have a ACL configured on that particular router on and apply on that particular interface, let's say here 5 Ethernet 0 by 0, and after that it will check the routing table or forwarding information base to basically route the traffic. It will check the Cisco Express forwarding table if we are using the Cisco router. You know about a CEF. So it will use the CEF table also for fast or high performance of the router. And Cisco devices, you can enable the CEF. Okay, so if you have enabled the CEF and doing the load balancing, so definitely it will send the one packet to one link and another second packet to second link, just like round robin. Okay, so these are couple of checks that router needs to perform, and once the particular first packet will go through with all these checks, now the router will forward this traffic towards the server. Okay, now the server will reply and come at the router interface again back. From here, it will packet will go and again it will reply. Okay. So once it will receive the particular packet on this interface FA0Y1, this particular, because see it will reply with the TCP SYN plus ACK. Here it will receive the SYN request and reply with SYN plus ACK. So this particular TCP SYN plus ACK packet, the second packet will also go through with all the checks like packet header, error, CRC check, again fragmentization, all the things whatever it processed while incoming the packet at ingress interface, and this is called the egress interface at that time. Again, it will receiving the packet back on that interface with SYN plus ACK. So it will check all the things again. So there are around 27 checks the Cisco routers can apply if all the features and all the services are enabled, just like PBR, policy-based routing, IPSLA, tracking, interface tracking. Okay, so these all things it will check and then send the packet towards the PC. Okay, so now the PC one will send the next packet back with ACK, that is called TCP ACK. It will go through with all above checks but I again spoke. So it will do that and forward that packet to server. So I am trying to tell you that each and every time, whatever the packets it is receiving at its interface, ingress interface, it will check every time the same checks, whatever it applies, it will check each and every time before forwarding the packet or data towards the egress interface. Same. Again, it will receive back that packet on that egress interface. Again, it will do the check, all checks, whatever it checked on that ingress interface. Again, it will do the same thing. So it will consume the bandwidth and resource intensive also. Now, Understand the router is not maintaining any kind of state of the session. And because of this, each and every request and reply packet needs to go through with all above 27 checks. In case of router, and suppose there is 20 GB file to exchange in between, and let's assume it will send 200 request packet and 200 reply packets. Total, it will exchange around 400 packets with each other, both the interfaces. And let's assume it is taking 2 seconds for each packet. So for entire data process, it will take around 800 seconds. Okay, so keep this thing in your mind, because once we will understand the next generation firewall, so we will compare this 400 packets and 800 seconds mechanism for this time duration. Okay, so far any question here, or you are getting bored? Okay.
No.
Yes. Yes, Raghu.
No question. No question.
Okay. Thank you. Okay, so yesterday we were talking about the legacy firewall and next generation firewall. Okay, so here I want some blank area. Checking. Okay. One edge next generation firewall. Okay. And another side, we will put the legacy firewall. Okay. This is legacy firewall. So next generation, like Palo Alto, Fortinet, okay, Checkpoint, Cisco FTD. I'm not writing all the names here. ASA, Juniper SRX, okay, Cyberom. I worked on the Cyberom. Initially, I started my firewall learning with Cyberom. Okay, Sophos, HP, Dell, and so on. There are many legacy firewalls also. In your network model, suppose here is the router, okay, and below the router, suppose this is the cloud, okay, particular company cloud network, and your router, cloud router is connected with your on-prem router, okay. Suppose there are two routers, okay, and high level diagram, there is a LT switch, and below here are distribution switches, and below the distribution switches there are access layer switches, okay. So here in between, this is the L2 switch, okay, but this switch is not an I mean logically this switch is not useful, okay. Why? Because suppose we are putting here the firewall, okay, we have created the VLAN here, two VLAN, one for ingress and one for egress. Here our firewall located, okay, here firewall, and here IPS engine, Okay, so logically, in this ingress VLAN, the packet will come here and go just like this, and any other device or module we are using, so it will we can assign and pull particular interfaces and assign to particular VLAN and use accordingly, and then traffic will flow like this. Okay, again, the outgoing traffic will go also just like this. Logically, it will flow the traffic, but physically you will see how the switch is installed here. That is different thing. Okay, so what happens here? Suppose, for example, here only the ASA is installed on the L2 layer 2 level. Okay, but actually the firewall is in use with the L3 level also. Organization can put the transparent firewall also for L2 data processing. That is different thing. But here, let's assume cut here. Firewall is directly connected. Okay. So this firewall, the packet will go and inspect at L3 and L4 level only. Okay. So this ASA, once upon a time, ASA was very popular in legacy firewalls. They are using Lina engine. Their chipset name is Lina engine. Okay. So what firewall will do? Firewall, this legacy firewall will inspect the data at layer 3 and the layer 4 only. Okay, we have 2 minutes for this. So legacy firewalls like Cisco ASA uses Lina engine to protect L3 and L4 traffic. It can work as a next generation firewall. How? Because this is the legacy firewall. So you can combine earlier. If you will check the FTD firewall history, they are using the ASA OS version 9.x that supports the FTD. But before the ASA 9 OS version 9, they were using for ASA only. So before FTD, there was one device in the market that is called Firepower. So later part, Cisco acquired that Firepower and using as a module only. In ASA firewalls, you will see if you are working on 5505 firewall or some series of models, you will see there are some separate module they are inserted. That is called a Firepower module. So if you are using the legacy firewall, you can inspect the traffic till layer 3 or layer 4 only. But if you want to inspect the packet till application layer, so you need to install the IPS engine separately. Later part, they merge